Solve and write your answer in interval notation. So here we have -3 times the quantity x plus 1 plus 16 is less than or equal to 2 times the quantity 6 minus x. So we're going to start this process a lot like solving a linear equation, and there's just a little extra that we have to do at the end. So we're going to distribute the -3 into the quantity x plus 1. So we have -3x minus 3. We'll bring down the plus 16 is less than or equal to. And now we're going to distribute 2 times the quantity 6 minus x. So we'll have 12 minus 2x. Now we'll combine like terms on the left. So -3 plus 16 is 13. So we'll have -3x plus 13 is less than or equal to 12 minus 2x. And now here, I'm going to collect my x terms on the left side of the inequality. So I'm going to add the 2x to both sides. I'm going to add 2x to both sides. And I'm going to collect the constants on the right side. So I'm going to subtract 13 from both sides. And so -3x plus 2x is going to leave me with a -x on the left is less than or equal to 12 minus 13 is -1. So far, all the steps are the same as if we were solving an equation, but now since it's an inequality, when I solve to get x by itself and divide both sides by a negative, the inequality is going to switch. So if I divide both sides by the -1, I'm going to result in x is greater than or equal to +1. So the inequality switches because I either multiply or divide by a negative. So my solution is a collection of values, not just a single value. So it's the set of all x values greater than or equal to 1 that's going to solve this original inequality. Now I want to write my answer in interval notation. So in interval notation, x values greater than or equal to 1 is going to look like a bracket around the number 1. The bracket includes 1 because I'm greater than or equal to. And numbers greater than 1 are going to go all the way to infinity. And I always use open parentheses around infinity. So it's the set of all x values in this interval. So I'm going to be formal and write the notation as x in, the symbol is in or belongs to, the set 1, including 1, all the way to infinity. Now we'll solve one more linear inequality. This one has fractions. So we have the quantity x plus 3 all over 4 is greater than the quantity x minus 1 all over 3 plus 1/4. Now I'm going to go ahead and eliminate fractions right away by multiplying both sides of the inequality by the least common denominator. Between all the denominators, 4, 3, and 4 again, the least common denominator is 12. So I'm going to multiply both sides here by 12. Now the right side has two terms, so the 12 is going to distribute to each. So the right side is going to be the quantity x minus 1 over 3 times 12 plus 1/4 times 12. Now let's go ahead and start reducing. So on the far left, 12 divided by 4 is 3. So I'm going to be left with 3 times the quantity x plus 3 is greater than the first term on the right. The 12 divided by 3 is 4. So I'm going to have 4 times the quantity x minus 1. And then plus 1/4 times 12, or 12 divided by 4, is 3. So basically we were able to reduce these fractions down so that now we have an inequality that looks a lot like the last one, where we can move forward by distributing. So we have 3x plus 9 on the left is greater than, on the right we have 4x minus 4 plus 3. So we have 3x plus 9 is greater than 4x minus 1 if we combine like terms. Now we'll go ahead and collect our x terms on the left, which is not necessary but pretty typical. to try to collect our x terms on the left and our constants on the right. So I'm going to subtract 4x from 3x. So the left side's going to end up as negative x. And then I'm going to subtract 9 from negative 1. That's going to give me negative 10. So I have negative x is greater than negative 10. And now I'm going to have to multiply both sides by negative 1 or divide both sides by negative 1 to get the x by itself. And because this is an inequality, the signs are going to switch. So I'm going to have x is less than positive 10. So we're going to multiply both sides by a negative, switch the inequality. So this is my solution. Written in interval notation, x values less than 10. Well, that's going to look like negative infinity to 10 with an open parentheses around both sides. So not including negative infinity and not including 10 because I'm strictly less than, not less than or equal to. Less than or equal to creates brackets. So here's my answer in interval notation.